Welcome back to day 2 of graphing quadratic functions. Again, we are looking at our two different forms for the equation of our parabolas. We have standard form and vertex form. So the first thing we're going to do is find the equation of the parabola given the following characteristics. So on example A, my vertex is -3, 3. So what this tells me is my h value and my k value. The other bare minimum piece of information I need in order to write the equation is A. So what I'm going to do is use this other point that's on my parabola, and I'm going to plug in that x and y value into my vertex form. So what I'm going to do is have y be equal to a times x minus h squared plus k. I'll know all these values except for a, and I'm going to work backwards to find the value of a. So what's that going to look like? Well, 1 equals, because that's my y value, a, that's what I'm solving for. My x value is -2. Minus h, which is -3 squared, plus k, which is 3. So to recap, this is y, I'm solving for a, this is x, this is h, and this is k. So starting from inside my parentheses, when I have minus a negative, that becomes plus. -2 plus 3 is 1, and again, I'm solving for a. If I move the 3 over, I get -2. 1 squared is just 1, and 1 times a is a. So a is actually -2. So I can go ahead and write my equation in vertex form because I know hk, and I just found a. So my equation in vertex form is going to be -2 times x plus 3 squared plus 3. And that's vertex form. Now, if I wanted to write it in standard form, I could take my vertex form and just expand it out. The first step of that would be to FOIL my parentheses, x plus 3 squared. Remember, don't be fooled and just think you distribute the square. You're actually multiplying the binomials together, and you have to FOIL. So, again, putting this in standard form, that's my first step, is to FOIL. Then I'm going to distribute a, which is -2. And then the last thing I can do is combine my constants. So my equation in standard form is going to be -2x squared minus 12x minus 15. And that's standard form. Okay, let's practice this again. On example B, I'm given the vertex and a, so I can actually go ahead and write my equation without doing any additional work. So vertex form for my equation is going to be, if a is -1, then negative x plus 3 squared plus 4. And then again, if I wanted to go to standard form, I would just need to expand it out first by FOILing, then distributing my a, which is -1, and combining my constants. And this is my standard form. All right, moving on to my next set of examples. What we have here are solutions to a quadratic, or you might see them called roots. Either way, what you are looking at here are the end result of solving the quadratic when it's equal to 0. And we're going to work backwards to find out what that quadratic was. So starting with example C specifically, if I have x equals 1 and x equals 2, what we're looking at here is the end result of somebody starting with a quadratic, factoring it, setting each parentheses equal to 0, and solving for x. So we are going to do those same steps in reverse to find the quadratic that started this whole thing. So starting with x equals 1, I want this to be equal to 0, so I'm going to subtract 1 on both sides, and I get that x minus 1 equals 0. Great, that one's done. Now on to x equals 2, I'm going to subtract 2 on both sides, and x minus 2 equals 0. Perfect, that one's done. So these were my two parentheses that I set equal to 0. So x minus 1 times x minus 2 was my factored form of my quadratic. Now that I know what my factored form looks like, I can get back to my original quadratic by simply FOILing. And that's going to be x squared minus 3x plus 2 equals 0. So if I had gone my normal route, I would have started with this quadratic, factored, set it equal to 0, got my two solutions. And instead, this time you were given the solutions, and now we just did every step in reverse to get our quadratic here. Okay, let's do the same thing on D. Again, I want to get each of these x equals to be equivalent to 0. So on the first one, I'm just going to add 2 to both sides, and now it's done. On the other one, x equals 1/4, the first thing I need to move is my denominator, and I undo that by multiplying by 4 on both sides. So I get that 4x is 1, and now I can subtract, and I get that 4x minus 1 is equal to 0. So again, these are my two parentheses. So x plus 2 times 4x minus 1 equals 0, and now my final step is going to be to FOIL. And there is my original quadratic. Now e is a little trickier of the two, 3 plus the square root of 2 and 3 minus the square root of 2. I can rewrite this as one solution, 3 plus or minus the square root of 2, and work backwards from here. The first thing I'm going to do is move the 3 over, so x minus 3 equals the plus or minus square root of 2. Now, to undo that square root, I'm going to square both sides. And when I'm squaring a binomial, remember that means I'm multiplying it by itself and I am foiling. So that's going to be x squared minus 6x plus 9. And then the square root of 2 squared is 2. So the last thing I need to do here is just move that 2 over. And it's x squared minus 6x plus 7 equals 0. All right, on to the back side. This is just kind of a review of transformations. Starting with number 1, this is our quadratic parent function, which means my vertex is at the origin, and I could plot a couple other points just to connect the dots. But essentially, what I want to make sure I see here is that my vertex is at the origin, and it's a regular parabola, my quadratic parent function. Now on 2, we should know from our knowledge of transformations that when I have minus 4 inside my parentheses, that means I'm shifting 4 units to the right. So my vertex has moved. Again, you could plot a couple points if you want, but my hope for you here is just to recognize that the only thing that's changed is I've moved my parabola to the right 4 units. My vertex has shifted. On to 3. I have a shift to the right 4 units again, but I also have a shift vertically up 6. So there's my new vertex, and everything else looks the same. Okay, on 4, I'm shifting 5 units to the left this time and down 2. And then everything else about my parabola is the same. And then last but not least, on number 5, my vertex has shifted to -2, +3, and that negative on the outside means my graph is flipping over the x-axis, which means it's going upside down. And so that's what that one would look like. So this is just to connect your prior knowledge with your new knowledge and recognize that you can get an idea of what these parabolas should look like on your graphs simply by knowing your transformations. And that will conclude our Day 2 notes on graphing quadratics.